In this module, I will build this very simple graph one methodology phase at a time. In this example graph, the Lavastorm coffee shop wanted to answer two business questions. Which of the customers visit more frequently than others? And which of the coffee items brings in the most revenue? Before I build this graph one step at a time, let me give you a little backstory. Meet Lavastorm. Lavastorm always dreamed of opening up his very own coffee shop. After a rocky first start, his coffee shop was finally in the black. He knew he wouldn't have succeeded without his most loyal customers, so he wanted to implement a new loyalty program and send his top 3 loyal customers some promotional items through the mail. In order to do so, he needed to know who those loyal customers were. Then the question was, what kind of loyalty program should he implement? Should he create a combo meal and implement a buy 4, get the 5th free? Or maybe buy 5 large coffees and get a small for free? His options were unlimited. To help him make a good decision based on what's best for his business, he needed to know which of his items was bringing in the most revenue. Good thing he has the Lavastorm analytics engine to help him find the answers to his question. Using the methodology template, I'll begin by acquiring the data sources. I can do so by either dragging the data source from my Windows folder onto the Business Rules Editor, or BRE, or by adding the appropriate node and locating the data source I need. It is recommended to enter a descriptive name for the node. This helps in producing a visual, self-documenting graph. Then click OK. Before I run the nodes, notice that I placed 2 of my data sources in the primary box and 1 in the secondary box. The primary data is data that is essential for the analytic process. Without this data, the analysis cannot be performed. The secondary data will provide extra supplementary information, which may aid or enhance the process. The reference data, which we didn't use, are data sources that have no value as far as the analytic process goes, but provide field translations which may enhance the results when viewed in a report. Now I can run the nodes. Let's take a look at the Transactions Brd Viewer. The Brd Viewer is a tool for viewing interim data sets produced by the node. It displays the first 1,000 entries of the data. What I'd like to point out at this step are the column names. Notice that all the data types are string. A data type defines the possible values for a field or variable, the operations that can be done on that field, and the way the values of that type are stored. To easily work with this data, I need to convert the columns to a more appropriate type. For example, date should be converted to a date data type. The easiest way to do this is by adding the Data Analyzer node. If I add the Data Analyzer node to all of the data sources, I can ensure all of the data gets converted. Since this is part of enriching the data, I'm going to add this node under the data preparation phase of my graph. To auto-join the nodes, all I have to do is highlight the first node, locate the second node, and then double-click to add it. Now I run the nodes. If I take a second look at the Transactions Brd Viewer, I see that the columns have been converted from string to a more appropriate data type. Let's also take a peek at the other output pins. The second pin displays the analysis of the conversion. I can see how the data type was converted, what the min and max value of the data was, what this min and max length was, if any data converted with a null value, and even the brain script used as part of the conversion. The last pin is a histogram of the data. The histogram displays the occurrence count for each discrete value in a specified column of data. Before I move on, I want to take one more look at the transactions data. Notice that some of the data are showing spaces. For example, the hot tea. The best way to remove these spaces is by using the Trim node. The Trim node removes leading and white space characters from field values within the input data set. As a best practice, I'm going to add the Trim node to all of our data sources. I want to make sure to use the converted data pins of the data analyzer nodes. Then I run the nodes. If I look at the transactions data now, I see that the spaces have been trimmed. Now that I have all the files analyzed and trimmed, I want to start combining the data. This will help me find the answers to the questions I asked earlier in the module. First, I'm going to join the transactions data with the customer info data by using the Join Inner node. This node will join my two input data sets and only output records found in both sets. Before I edit the node, I need to join all the nodes together. First, I drag the output pin for the customer info data to the first input pin on the join node, and then drag the output pin for the transactions data to the second input pin. Once they're joined, I double-click to edit the node. Now I can edit this node. First, I start by naming it. Then I sort the outputs and enter my input keys. The benefit to joining all the nodes together before editing this node is that the column options pre-populate. First, I select my left input key. This is the data coming from the left or top data source, in this case, our customer info data. Then I select my right input key for my right or bottom data source, my transactions data. Notice that this node pre-populated some code in the right input key field. This code means that the right input is going to use the same column name as the one we selected in the left input key field. In this case, the code is true, so I can keep it as is. If I needed to, I could delete the code and select the column I want to use. Let's go ahead and run this node from the edit screen. This allows me to fix any errors without having to return to the edit screen. Let's see what my data looks like now. If I access the Brd Viewer, I see that the customer info data joined with the transactions data, and now all of my transactions are linked to the account ID that placed it. Now that I've got the first data set ready to go, I need to combine it with the prices data, which gives us the cost of each coffee item. I could use another Join Inner node, but in this case I'm going to use a Lookup node. The Lookup node enriches a large set of data in the primary input with a small set of data in the secondary input. As with the Join Inner node, I'm going to combine the customer transaction data with the prices data to the Lookup node prior to editing it. Now I can edit this node. First, I select my input key. Then I select my lookup key. Next, I run the node and look at the Brd Viewer. When I look at the Brd Viewer, I see that the coffee prices have combined with the customer transactions. However, as I take a closer look, I notice one of the items is pulling in a null value. If I sort by price, I see that all of the chocolate chip scone orders are coming in as null. Since we need the price to determine the highest revenue item, I need to go back a step and look at the original price data. Looking at the Brd Viewer for the price data, I see that chocolate chip scone did in fact have a corresponding price. So why is the value of null appearing when I combine all the data? Let's do some troubleshooting. First, I'm going to add an xref node. This node joins two data sources using a comparison expression to determine if specified data is found in one source versus the other, as well as any matching data. I'm going to join the customer transaction data and the prices data. Now, let's edit the node. First, I sort the node, then select my left input key. Since I know chocolate chip scone is what I'm troubleshooting, I'm going to select item. Then I run the node. Now, let's take a look at the output pins. The left orphan pin shows me the coffee item that is present in the customer transaction data source, but not in the prices data source. In this case, chocolate chip scone. However, if I look at the right orphan pin, I see that the cross-reference indicates that chocolate chip scone is present in the prices data source, but not in the customer transactions data source. So how can this be? One possible theory is that somewhere in one of these files, chocolate chip scone is misspelled. To test this theory, I'm going to use a fuzzy join node. This node compares data sets using keys which may not match exactly, but are intended to match, using fuzzy matching algorithms. For example, TIM and TMI. Once I've added my fuzzy join node, I'm going to join it with the XREF node. The left orphan pin on the XREF node joins to the left pin on the fuzzy join node, and the right joins to the right. Now I edit my node. I'm going to use the fuzzy tab on this node. First, I choose my algorithm, then enter a threshold of 1. Next, I select my left and right fuzzy expressions. In this case, my input field of item. Last, I run the node. Looks like I got an error. If I hover over the node icon, I see that my error is due to the fact that both the left and right data sources have the same field name of item. It suggests I change the name of the right field, or prices data source, to avoid issues. To do that, I go to the Optional tab. And in the right prefix field, I'm going to enter right. This way, I can quickly identify which column comes from the prices data versus the customer transactions data. Now, let's rerun the node. If I take a look at the multi-match output, I see my item column from the customer transactions data source and my right item column from the prices data source. Close examination tells me that chocolate chip scone in the prices data source is in fact misspelled. Now I can go back and fix my original issue. Remember, when I combined the customer transactions data and the prices data, chocolate chip scone was coming in with a price value of null. Now I know that's due to the misspelling in the prices data. So let's fix that spelling. To do that, first I unjoin the prices data source from the lookup node. Then I add a filter node to the trim node. The filter node is used to transform the data, in this case replacing a misspelled word with the correct spelling. Now I could just go back to the original source, make the edit, and then rerun the graph, but I want to show you how I can use a replace brain script code to fix the spelling issue. First, I'm going to name this filter. Then I'm going to enter the brain script code. Notice there's already an omit all code. I could keep this as is and then add a new column with the fixed spelling, or change it to admit only the price column. This way, as I fix my spelling issue, I can output it into the item column without firing any errors. I also won't have to change any nodes down the line to accommodate a new field. When I write the code, I want to output the item column as a replacement, changing chocolate with chocolate, and as a column called item. Then I run the node. When I look at the data, I see that the columns outputted were price and item, and that the chocolate chip scone is now spelled correctly. Before I continue building the graph, I need to rerun the lookup node and get the updated data. If I take a look at the Brd Viewer, I see that I no longer have a null value for chocolate chip scone. I have resolved my initial issue. I can continue to answer the two questions: which of the customer visits more frequently than others, and which of the coffee items bring in the most revenue. Let's do some impact analysis. To answer the two questions, I'm going to need to aggregate the data. For this, I will join two aggregating nodes to the lookup node. The aggregating node aggregates the input data by user-defined input fields. For example, the first aggregating will aggregate the data by customer, and the second by coffee item. Let's edit the first aggregating node. For this node, I'm going to group by customer. Notice there is some code defaulted. I'm going to edit this code. First, I need to indicate that I want to count the number of visits. Then I need to specify the columns I want to output. Since I only care about the customer info and how many times they visited the shop, I want to output only those columns containing customer information. I also need to make sure my count gets outputted into a new column. Then I'm going to keep the where last in group code. This makes sure that the count for a particular customer ends when the data reaches a new customer. For example, the run will count all of the John Smiths until it reaches Jane Smith, and then it will start a new count for Jane Smith. Once the script is complete, I need to tell the node which column to group by. Now I run the node and view the data. Notice only the customer information appears and that there is now a column called Total Visits. But also notice that the data is sorted by account ID. When I publish this data, I'll need to see it sorted by highest total visits first. To do that, I need to add a sort node and join it to this aggregating node. The sort node sorts the inputs based on the designated sort keys. For example, highest total visits. First, I name the node, then I add my sort parameters. In this case, I want the total visits column to do a reverse sort. Let's run the node. If I look at the Brd Viewer, I see that the data is now sorted by the highest total visits first. Now that the first question of most frequent customer is answered, let's take care of the second question of highest revenue coffee item. I name the node and add in my code. This time I want to do a sum on the price column and only output data related to item and cost. Then I pick my grouping and run the node. Looks like I got an error. If I look at the error, it says that my input is not sorted. This is in fact true, as up to this point, the data has been sorted by account ID. Since it's the item I care about, I have to sort the item column. To do this, I need to go to the Optional tab and select True for my sort input. Now I can rerun the node. If I look at the Brd Viewer, I see that only the item column and the new total cost column appear. As with the customer data, I want to sort this one by the highest revenue item first. I add a sort node and join it to the aggregating node. Then I name the node and add my sort parameters. Now I run the node. When I look at the data, I see that large coffee brings in the most revenue. The last step in this process is to publish my data. There are many publishing options available to you. For this graph, I'm going to output to Excel. Notice when I add the node that there is only one input pin, but I have two output sources. The great thing about these nodes is I can always add more input pins. To do that, I simply join the data sources. This will auto-produce two worksheets within Excel displaying the two data sources. Now I can edit my node. The first thing I need to do is indicate a location, as well as the name of the file. At this point, I could run the node. However, I want to name my worksheets in Excel so that I know what data I'm looking at. To do that, I click on the I/O tab. Under the Inputs box, I see our two input pins and which data source they are linked to. All I have to do is change the name. Now I can run the node. If I open the Excel file that was created, I see a worksheet for most frequent customers and a worksheet for highest revenue item. My graph is complete.